Okay, another method of simplifying radicals is to use the factor tree. So we're going to use our example, 12. We broke down 12 to be the square root of 4 times the square root of 3, because 4 is a perfect square and 3 is a prime number. That's how we got 2 square roots of 3. If we use a factor tree, we can use any number. So if we use factors of 6 and 2, 2 is a prime number, 6 is not, so I continue factoring and I circle 3 and 2 because they're prime numbers. Notice I have 2 2's, so that tells you the 2's outside the radical and the 3's inside the radical. I get the same answer whether I use the factor tree or the perfect squares. Here's another example, the square root of 18. If I look for a perfect square, that would be 9 times 2, because 9 is a perfect square. So if I break that down, the square root of 9 times the square root of 2, that would simplify to be 3 square roots of 2, because square root of 9 is equal to 3. If I use a factor tree, I can use 9 and 2. 2 is my prime number, so I circled it. My factors of 9 are 3 and 3. Notice I have 2 factors of 3, so that would put 3 on the outside of the radical and 2 inside because it's a prime. My last example of using a factor tree will be the square root of 24. So the square root of 24, the perfect square is 4 times 6. 4 is a perfect square. So if I simplify that, I can say the square root of 6 times the square root of 4. 6 is not a perfect square, so I have to leave it inside the radical. The square root of 4 is 2, so it goes outside the radical. 6 is inside. If you use a factor tree, I can use 8 times 3. 3 is prime, so I circled it. Factors of 8 are 4 times 2. 2 is prime, so I circle it. Keep factoring 4. It's 2 times 2. So notice I have 2 factors of 2. So that would be 2 outside the radical. The 3 and the 2 don't have a double, so they go inside. And if I multiply to simplify the radicand, that would give me 2 square roots of 6.